Welcome back, everyone. In this lecture, we'll jump to a Jupyter Notebook and start creating basic functions in Python. Let's get started. Okay, here I am at a fresh Jupyter Notebook. As a quick note, the lecture notebook that goes along with this is called Functions, and throughout this series of lectures when we talk about things like print versus return, adding in logic inside a function, tuple unpacking, etc., that's all within this singular Functions notebook. So it's a longer notebook that's going to have several video lectures attached to it. Okay, let's get started. As we mentioned, you first have to start off with the def keyword. Notice that it starts highlighting the special syntax behind it, and then we decide on the name of our function. For example, let's have a function called say hello. Then we have open and close parentheses and the colon. And then when you hit enter, you'll notice an automatic indentation, which happens after you click a colon in Python. And basically what that means is anything inside this indented block is going to be called when you execute the function. For example, if I say print hello, run that. Then, if I later on, somewhere else in my code or script, call say hello, open and close parentheses, then it's going to execute the block of code inside this function. That means that if I had more complex code, like a bunch of print statements, hello, how are you, imagine for a second that I wanted this all in 3 lines for some reason, then I no longer need to write those print statements 3 times. Instead, I just need to call say hello 1 time. Now note here the difference between calling say hello with parentheses versus without parentheses. If you call it without parentheses, then it's actually not going to execute the function. Python will just report back that say hello is a function. Keep that in mind, that when we're calling functions, in order to execute them, we have to add on this open and close parentheses. So if you see something like this, it means you're not actually calling the function. You need to add on the parentheses. Okay, so the main point of a function is to execute the block of code, especially when you plan on repeating that block of code. And realistically speaking, we're probably going to take some input parameters or input arguments into our function. So let's go ahead and continue. I'm going to overwrite say hello. And then I'm going to say, let's go ahead and call this name, that it takes in some name parameter. And then it's going to print out, using an f-string literal here, hello, name. So what is this doing? Well, it takes in some argument called name, and then it's going to insert it right here so that it will report back hello name, which means if I call say hello, and I pass in the string Jose, it says hello Jose. A couple of things to note here. Technically, I can call this variable whatever I want. So let's go ahead and show that. I could call this jelly, and then this would have to match up here, jelly, run that, and it looks exactly the same. So typically what you should be doing is just providing variables that make sense to you. In this case, name makes a lot of sense. The other thing to note here is, let's imagine I forgot to pass in an actual value. So I just said say hello. Well, in this case, Python is going to complain. And the way to read this error is it will say it's missing one required positional argument called name, which is essentially trying to tell you, hey, we need to know what name is as an argument in order to actually execute this block of code. So how can you fix this? Well, one way is just to provide the value as mentioned. Another way is to provide what's known as a default value. And you do this with an equal sign up here, and you can provide some default value. So what this means is if name is not provided, then we'll go ahead and use this default. And in this case, we'll just say equals and whatever you want the default string to be. In this case, I literally just put it as default. So make sure you keep running these cells in order to overwrite your old function code. And then let's call say Jose or say hello Jose. It says hello. And now what we're going to do is leave it blank. Previously, when we left it blank, we got an error. But now that I reran this function definition and run this cell again, it says hello default. So it no longer produces an error. Instead, it will reach in and find the default value for that function. All right, now as we noted in the previous lectures, typically when it comes to a function call, you're not actually just going to print stuff out. Instead, you're going to use the return keyword. So let's see an example of that. I'm going to create a function called def add num, and it takes in 2 numbers, num1 and num2, and it's going to return their sum. Return num1 plus num2. And one of the most common questions I get from beginning students is what's the difference between saying print in a function versus return in a function? And the main difference is that return, instead of just printing out the results, is actually going to allow you to save them as a variable. So we'll say add num here, and in Jupyter Notebook, if I were to just say something like 1020 add num, notice that I see the result anyways, 30. But because I'm using return, I'm actually able to assign it to a variable. So I can assign it to a variable instead of seeing the result, and then call later on somewhere in my code that result. So let's actually see this between two functions. We will call one print result that takes in two parameters. Let's go ahead and call them a and b this time. And this one just prints out the sum, a plus b. We'll create a very similar function called return result. And this one is going to return a plus b. This way we can actually see the true difference between them. So let's first start off by running this print result function. So I will say print result. I pass in 10 and 20, so 10 plus 20 is 30. And when you run this, notice it prints out 30. You should also notice that unlike before, there is no output cell showing you that a variable is being returned. Instead, it's just printing out the result. So let's imagine that I wanted to actually save the result, 30, to some result variable. What I cannot do, since I'm just using print, is the following. If I say result is equal to print result, then Python is just going to print this out, and it's not actually returning anything to this result. In fact, if I check result and try to run it, I don't get anything back, because the type is none type. Because again, print result is not actually returning anything to be saved. It's simply printing an output and then closing off the function. In order to actually do this sort of thing, where I want to save the variable, I would need to return a plus b. So let's see the return result function now. I say return result, 10, 20. I see 30 is the output. Note that Jupyter lets you know something's being returned by showing you this output cell, just signifying that it's not being printed, it's being returned. And now what I can also do is say result is equal to return result. And now if I call result, it's actually the number 30. So again, just having print here is not going to allow you to actually grab the result. Now that doesn't mean you can't use print and return together. If for some reason, keep in mind it's not super common to do this, that you wanted to see both the printed result and be able to return it, then you could just do something like this. You could say def, call it myfunc, takes in a plus b. It will go ahead and inform the user by printing out a plus b, and it will return a plus b. Now this is not too common to do this. You usually either just return or just print. Most common just return. But if for some reason you find yourself saying, in my large script, I want to be able to kind of view the results as they're coming in, then you could print and then also return, which kind of allows you to get the best of both worlds, so to speak. So I could say result, my function, 10 and 20, run this. Notice that this print gets executed, but then this return also gets executed. So now result is equal to 30. Again, not super common to do this, but when you're debugging sometimes as a beginner, it is useful to have these print statements within a function, so you can see what's going on internally. Now the last thing I want to point out in this lecture is the fact that we were just saying a plus b in the function. But keep in mind, we weren't actually checking what the data types were. So if I called a function sum underscore numbers, it takes in num1, num2, just as before, and it returns num1 plus num2. Nowhere in this am I actually checking to make sure these are numbers. And if you're coming from another programming language that is statically typed, that is to say you have to make sure and define the data type of a variable before you call the variable, then you may not be used to this. Python is dynamically typed, which means I don't need to specify beforehand what data type I expect num1 and num2 to be. That allows you to program a lot faster, but it also leaves you open to possible bugs. Let me show you what I mean. If I say sum numbers, and I say something like 10 and 20, I get the result I expect, 30. But that can get dangerous when I say something like some numbers, 10 as a string, and 20 as a string. Since these are strings, the add sign will actually concatenate these together, meaning I get the result 1020, which almost looks like 1020, which is not what I was expecting here. And when you're taking user input, it will show up as a string. So recall from the useful operators lecture that the input function returns a string. So that means if you find yourself creating a function that another user will be interacting with, you should probably be making sure to check the type of the data before returning the result. And we're actually going to have a much deeper discussion on this when we start heading towards your milestone project. So keep that in mind for now, and later on we'll show you different ways of having to deal with this and making sure the right data type is being returned by a user. So keep this in mind for now. Later on we'll show you various ways of potentially addressing it. Okay, that's it for now. Coming up next, we'll show you how to add in logic to internal function operations. I'll see you there.